Hello everyone, welcome back to another video. We're looking at Advent of Code 2019 Day 4 in Uiua. And this one, there's some cool array stuff I think in the way that we implement these validity rules, but ultimately it's kind of slow because we're just having to implement and iterate over these 500,000 numbers. But anyway, let's take a look at it. I think it's pretty cool. So we need to check for these numbers, do we have two adjacent digits, at least two adjacent digits that are the same, and going from left to right, the digits never decrease, so it's monotonically increasing. So let's take this number as an example, and we can parse this to get a number out of it, and we want to look at the digits individually, so for that we can use the base function, which will convert the number into its digits in base 10. And we now need to check that it's always increasing, or in this case always decreasing, since it's least significant bit first. So let me make this a valid number. And then we can check, okay, how do we look at these pairs? So we can look at pairs with the stencil operator, and we could check that these are in the right order. But we can also do it all at once with rotations. So if we do this, so we're basically saying shift the whole number over by one position. So you can see that it's all shifted to the left one, and because I filled it with 0, this 6 didn't loop around to the end, but a 0 was shifted in instead. And now we can simply check that it's greater than or equal to at all positions. And this gets us what we want. So you can see if I put a 0 here, then we have this 0 indicating that in this position it is actually decreasing. So this should be invalid. So in order to combine these into a single Boolean, we can use an AND reduction, which in Uiua is a multiplication reduction. So basically put multiply in between all of these numbers by reducing. And you can see if I make this a 6, then we get the 1. So this is our mono check. And then we want to check that at least two digits, adjacent digits, are the same. So for this, we can use the run length encoding, and you can see if we do that with unkeep, then basically what we're getting is this run length encoding of the original vector. So this is saying there was 1, 6, 1, 5, 1, 4, 1, 3, and then there were two 2's. So this is exactly what we're looking for, because we basically just want to check in this vector, was there ever something at least 2? And we can do that pretty easily. We can put a 2 in here. And I'm using reach 2 here. This, you can see it calls a function skipping the second argument. 2 is actually a sort of no-adic function. It's like a function that takes 0 arguments and returns a 2. So this is just a kind of shorthand. I want to get rid of this other array down here. We don't need it. So I'm just using reach 2. And then we just want to check greater than or equal to. And you can see that we do have an element that's greater than or equal to, and we want to do an OR reduction. So in Uiua, we can use OR, and we can do an OR reduction. And we get our 1 out. So this is our check for the duplicates. And part 2 is pretty much the same, except we just have to make sure the two adjacent matching digits are not part of a larger group. So we can see here that this 444 is not valid because it's part of a larger group. But here you can see that these fours, that would be invalid, but these two twos are still there, so it's fine. So really the only difference here is that for part two, this needs to be equals rather than greater than or equal to. And in this case, it passes both because there's only two, but if we were to put another two here, then you see that this is now 0, meaning it's invalid. So because part two, 1, and 2 are so similar, I don't really want to repeat the code between them. So I'll make a macro here, which basically just applies these two functions and then does an and reduction between them. So I can maybe quickly show that we want to fork, so we want to call two functions on the same vector. And the functions we want to call are this one and this mono function. So we want to do something, oops, like this. And this gets us our 1, meaning it's valid for the mono function, but it's invalid currently for this function because we have these 3 2's. But if we were to remove 1, then we have them both being valid. So we just want to do a multiplication to AND these together. And we can make this a macro, as I said. So it needs a placeholder, and the placeholder should be here. And basically, this placeholder, we can fill it in later with the function that we want to put here. So now part 1, as we discussed, is just valid with greater than or equal to, and part 1 is valid with equals. So this is now how we can solve both parts. And the actual thing we need to do is generate this range of 500,000 numbers, apply this validity function to all of those numbers, and then count how many are actually valid. So it's it runs in not that fast. I think in the pad online it would even run pretty slowly, but I think in my native environment it runs in like 5 seconds or something, so it's okay. What I can do though is show how you can construct a range. So let's just go from 50 to I don't know 22 4, I guess, something like this. And of course it's going to complain because it's a new format. So now we need to parse this string into two numbers. So we can partition parse by not equal to the hyphen, and this will get us our two numbers out. And then we want to apply a function between these numbers that will get us the range. And that idiom is under subtract range. And in this case, we probably want to subscript it with a 0. So this gets us back our, in this case, 551 numbers. I can go into this a little bit. It's a little bit complicated to explain, but basically what we're doing is, if I uncouple these, the goal is basically we want to subtract the smaller one from the bigger one, and that gets us 550. And this is the range. We want to generate this many numbers, so we can do range. But we want to add back this starting number. So we could do something like this, where we keep with off, keep the first argument under the output, so now we have it here. Then we can generate the range, and range 0, range subscript 0 makes it inclusive, by the way, so that's why I was doing that. And then we could add here. So this basically gets us what we want, but we can use under for this instead. So under will do a transformation and then do an operation, and then undo that original transformation. So the transformation is subtract this starting value, then call this range function, and then undo that original transformation by adding this starting value back, which is how we're able to do this. And as I said, we're applying it here as a reduction because it's going in between these values. So that's how we can get that. And then we can call base 10 like we did before, and now we get all of our numbers. And then to each row, we want to apply both P1 and P2. And now we get back our Boolean vectors that indicate whether they're valid, and we want to do a plus reduction on both of them. Both is just calling the same function on two sets of values. So yeah, I think this is pretty nice. Some pretty cool stuff that we have in here. And I I think given that it is sort of inherently iterative to go through all of these, I think we still did some pretty cool array-based things. So anyway, I hope it was informative. Hope you enjoyed it, and I'll see you in the next one. Thanks for watching.